So welcome back, and this is a question called same tree, and it's an easy tree traversal question. And so essentially what we're going to do is we're just going to traverse these two trees that were passed here and just check if they're the same one. And so if they are, then we return true, otherwise we return false. And so essentially what same is that they're identical in shape. So wherever there's a node on one, there should be a node on the other, and then their values should line up. So it's a really simple question. We're going to be using a recursive approach for this. So if you're looking for the iterative one, I'm not going to do it at least for this video, maybe in a future one. But yeah, so let's get to it. So the first thing that we're going to want to check is that if the left node tree, or I guess tree P, is null, we should expect the other one to be null. And so that just means that wherever there isn't a node on one tree, there should not be a node on the other. And so in this case, so if P is null and the other one's null, then we want to return true. So in the simplest case, say we just pass two null trees here, so they don't even exist, then they should be identical. But in the more complex case, well, okay, just wherever there isn't a node on one, there shouldn't be a node on the other. And so the next check that we want to do is say, okay, if P is null or Q is null. And so this works because, well, okay, if they're both null, return true. But if one of them's null, then we know that the other one isn't, since it got this far. And so we want to return false in this case. Because if one's null, then and the other one actually has a node in that location, then they're not identical because, well, one has at least, one extra node or has a node in a location where there isn't a node in the other tree, so they don't match up, so they're not identical. So we want to return false in that case. So otherwise, we want to return, and this is kind of several cases here. So if we want to return three cases, and so this is where we're going to have our recursion. And so if P is the value of P, and we can do P.val because we know that P, if it got this far, it's not null. So we know it won't error out there. So it is equal to the value at Q. And so while we're iterating through, or I guess recursing through all the levels in our trees here, we want to check that at each node, the values are equivalent. And then what we're also going to want to do, and this is where the recursion comes in, is now we're going to want to recurse on the left nodes and on the right nodes. So we're going to just call the same tree method. And we will get the left value of P. We know it's not null if it got this far. And then same thing with Q. And now we want to do the exact same thing, but on the right side. So we just run that. Just an error. We need an extra equal sign. Try submitting. Success. So yeah, so what this is doing is we want to compare. Whenever we go left, we want to compare the left node with the left node. We want to compare the right node with the right node. And so in this case, it says, okay, these aren't null, none of them are null, so it gets passed here. We then return, okay, this is true because 1 is equal to 1. And then we'll call is same tree on the left side. So we evaluate that, okay, the left one and the left one, they're both equal to each other. They don't have any nodes past this point. And so then we come back and we check, okay, we evaluate this method here, comparing the right node with the right node. They're both equal in value. And so then that returns true. And so because all three of these evaluate to true, in the end, this would return true. So yeah, I hope that helped, and good luck with the rest of your algorithms. Thanks.